ladies. This time with Joe Virag. He's going to talk about PID loop tuning, which is actually something I think is really, really interesting. And I think it's one of some of the Wild West that's still around.
Isn't that the truth?
It is. It is. It's the way that it's done. Um, but for me, my update is because so you can see that Nikki and Courtney are not here, so I'm doing this one by myself. Um, Nikki is moving, and Courtney is doing interviews, so they couldn't join me. But I am working on OT Skatacon, and that's my update. Um, Hope everyone is doing well. Um, so yeah, let's jump into Joe. Why don't you tell us a little bit about your story, how you got where you are,
Hmm.
before we get into a really cool demo of temperature control.
Sure, thank you. I just want to start out by saying thank you to the automation ladies for this invite. It really is an honor just to be a part of this and to be able to share the things that we're going to share for this hour. So I just want to say a big thank you and a shout out. Um, yeah, out of college, I went. I'm in the Detroit area, by the way. I'm in Livonia, Michigan. Been a local salesman here for a long time, and just done a lot of startups over the years. And we'll kind of get into that with maybe a couple stories or two along the way. But out of college, I went to work for a company called Acromag, and that was really my introduction to instrumentation, process instrumentation, 4 to 20 milliamps, control loops, signal transmitters, isolators, alarm relays, all sorts of process instrumentation, and ground loops also. Found out about ground loops at that point. And it was kind of there that I met my first mentor, a guy by the name of Rule, and he was really an engineer's engineer. And I I have been fortunate over the years to have kind of three mentors along the way. And Rule was the first of them, and he could explain everything to me in terms of instrumentation, process philosophies, industrial industrial process control, and in a way that was understandable, and that laid a foundation for me. And then after there, went to Omron Local Sales, Omron Electronics, got introduced more into the automation market right through Omron, and and then a funny thing happened about almost 4 years into it or so. I was at a vendor event with a distributor, local distributor here in Michigan, and uh, they are also a Watlow distributor. So one of my counterparts from the Watlow Detroit sales team was there, and we ended up talking. And he goes, "Hey, if you ever think about making a move, let us know." And so a little while later, I kind of looked at Watlow and thought, yeah, that kind of looks like a company I'd like to work for. And so I contacted him, Ted's his name, and talked to the team. Everything worked well, and I signed on as a rep for Watlow and was there for 26 years. And it was just a great upgrade and a great experience for me. And it was at Watlow that I kind of met my next two mentors. And I'll talk about maybe Owen first because I'm going to get to him later on in terms of a story. But Owen was a field app engineer for Watlow, and he was brilliant with PID. I mean, he just knew PID control like it was nobody's business, and having him available to my customers as well as the other Watlow tech support just gave me the confidence just to go forward with jobs and with projects that I might not have done. As a salesman, you have to have you have to have backup. And when you have that backup, it just really means the world. And the second mentor I met along the way was Jim, a customer of mine, a mechanical engineer, PE, and he taught me everything about mechanical. If I had a mechanical question, I'd call Jim. And that because Watlow is kind of a line that, in terms of my customers, it's funny, they treated heaters a little differently. Watlow is heaters, sensors, temp controls. That's what Watlow is. And and some customers link or treat a heater as a mechanical device. It's physical, it's kind of out there on the machine. Other customers treat it as an electrical device because it has two wires, or three if it's three-phase. So you get a kind of mix when you're dealing with the customer. Sometimes you're dealing with mechanicals, sometimes you're dealing with electricals. So it forced me to have to become better mechanically to deal with those customers, whereas before my background was all electronics and electrical. So it really was a growth opportunity for me to get the mechanical in, because PID control, you called it the Wild West, right? I mean, it's been around forever, and it's just solidly entrenched in process control, and it's very mechanical. As much as I really thought when I got out of college that it's an electrical world, no, not really. It's a mechanical world. And electrical is just kind of along for the ride. And electrical, though, can fine tune the mechanics. And that's where the temp control and process control comes in. And I'm going to show you a little bit. I've got just a little thing here. I've got a kind of a stable load, if you will, and an unstable load. And we can see them visually. And so when you look at it, and what does that mean? Well, an unstable load, system means no matter how much you tune it, won't help. You're capped, and hopefully that'll become a little bit clearer. So anyway, Watlow is just really an opportunity to really marry the electrical and the mechanical aspects of control for me, and to really just grow with the company. And let's see, can you see the screen?
Yes.
Okay, awesome. Okay, this is the main screen of PID Navigator. And PID Navigator is a software, HMI software that I wrote after I left Watlow. It actually originated with a conversation with a local distributor here in the Detroit area, Hiwatt. I talked to them after I left, and just about, okay, what can we do together? Because after I left Watlow a couple years ago, I had plans to represent a couple companies and carry on my career. And they said, we could use a software package that's generic in nature and to talk to this certain family of Watlow controls. They said, we think we can sell it if you had that. And I thought about it, and as a salesman, I could see where they were coming from, because it seemed like it was a product gap. And a lot of people, Watlow included, I'm going to pick on Watlow just because I know them so well, but they make great products. And a single loop display, I don't know if I have one here somewhere. I did have one here somewhere. You have the little display and the push buttons like a 16th DIN or a quarter DIN, controller. Everything's right there. But when you get into a multi-loop control situation, you lose the inherent display, and the operator interface. So you're left with, the hardware, and you have to come up with something. I wanted to get customers on their way quicker with that. And that was another part of the software that I wanted to bring forth, is to get customers on their way quicker. I've been involved in a number of startups, Allie, like I mentioned, and you pick things up over time. And so I thought I could put this into software and bring out some of the important registers that I felt were important, that I would have liked to have in all the startups that I've done, and to expose those registers. And also, I kind of wanted, this is a way of me giving back to those who want to learn more on PID control, because now, again, I'm biased, I wrote it, but in here is the information presented to you in a way that I think is digestible and you can learn and grow with. And that's what the mentors did for me. That's what I'm trying to say. And again, I think there's a gap. I think there's a place for this software with that product line. And but it was a challenge because they had to be generic. I don't know what the customers are going to do with it. And it could be an adjunct to their PLC system. It could be a local display. It could just be a standalone system where they want to do temp control. Don't really know. So there's just some interesting aspects to it just to overcome. But I'm not really going to start with the software right now, Ellie. I'm going to start with a Watlow spec sheet because I think it's best just to start with the hardware, and then this will make more sense.
Great. Yeah, I'm familiar with Watlow in my coffee days. Watlow temperature controllers and Watlow limit controllers.
Right. And it looks like I cannot see the spec sheet to bring it up. So we're just going to have to do a little pretending, I think. Would you say about live demos?
There's always something that's going to go wrong in a live demo.
There is. There surely is.
It's part of how we do live demos with Automation Ladies for sure.
Let me get out of this. Just take a second to see if I can get it back, and we will continue on. Let me see if this makes sense. Okay, do that, and if I come here now.
I saw it earlier.
Yeah, it was there, and
it was working.
It was working, and then now it is absolutely gone. Okay. All right, so let's continue on. What I want to say about the hardware, I can show you. I think I can show you a module actually. So here's a plan B. Here's a rack of modules. You can see part of it.
Yep.
In the corner of the screen. And each one of these modules has 4 connectors. And if I remove this module, if I can, oh, I'm back, there we go. Let's do it the old-fashioned way. So you have 4 connectors on a module. And the unique thing about this module is each of these connectors represents what I call a slot. And each slot can be either just an analog input. In the case of one of the slots, it can be 6 digital I/O, or it can be a PID channel, or it could be a safety limit, an FM safety. So there's a tremendous amount of granularity with this, and you can go from 1 to 256 slots in a system. I support from 1 to 20 of them, up to 20. But so in going through, when I was planning the software and designing how to deal with all of this variability, It was in its own way a challenge because, again, I don't know what the customer's going to do. And but I was able to do it with up to 20 loops. It could be a PID channel, a safety limit, or any combination in between. And it works, and they all kind of coexist happily. So let me see if I can go to the software now, and hopefully that shows up. Can you see the software?
Yes.
Awesome. Okay, so here's the main menu of the software, and this runs on the WinTech HMIs only, and it supports the Watlow, the RM modules, specifically the RMC modules. And Watlow distributors can, answer your questions on the RM. I can answer your questions on the RM if anyone wants to contact me. No big deal, but it needs to be an RMC module. There's various modules, and then there's of course the communications module, the Ethernet module. So this is the main page of the software, and if again, as long as we're going to pretend that we just got this software. So what are you going to do? Well, a good place to start would be setup. And the first thing you should want to do is assign the zones. And what does that mean? Well, that means you're telling the software what's where. Like module or zone 1, the first slot, in this case, in the system I have here, is a safety limit. Module 2, the first slot, is a PID loop, and we're going to be working with zone 2, slot A. We're going to be working with this PID loop and a little bit with this one, this one also. Hold on.
Essentially mapping your IO or mapping your.
It is. Exactly. It's you're telling the HMI, you're telling PID Navigator what is where in the hardware, because the hardware comes first, the Watlow hardware, and then this builds on top of that. So and then in the last slot I have digital IO. So you can select this. Now the HMI front end, the part that I wrote, is generic. It just works for any RMC module that you can throw at it, up to 5. Now, you mentioned the link. This is what you tell the PID Navigator. The other part of the link is inside the RM rack. It's a data table. And that data table now is the communications link between PID Navigator and the hardware. So when you get the RMC modules, tell me, okay, module 1 is this part number, module 2 is that part number, module 3, whatever, is this part number, and then I create the data table. At this point, that's not automated. That's what I had to start with, so that's kind of what it is. But that data table now, the user, the new user, would put that into your Watlow software, your Watlow setup software, which I can show you, and one time. And then it gets it into the Watlow hardware, no problem, and then you do your control strategy with your Watlow software. After that, you don't need to worry about it. It's there, and you can do whatever you want after that in terms of PID, alarm, whatever strategy is important to you for the job. So after you set up your zones and tell it what's there, there's a companion part of the program, which shows an unlock. This is kind of an equivalent of an in-app purchase, just a simple lock and an unlock code. This is an adder. It's Smart SCR. One thing I wanted to do with the software, it was bring out all of the information on the loop. And on a heating load, nothing is in more close contact with the heating load than the SCR. And the SCR sees the load voltage, it sees the load ohms, it sees if there's a bad connection, it sees if a heater circuit opened up, it just sees everything associated with the load. So what I wanted to do here was bring out the SCR data to the user so they can see the entire loop. So much like setting up the zones, when you set up the SCR, there's 3 models that I support, 2 of them made by Watlow, one of them's a Eurotherm, Aspire AT, Aspire DT, and then Eurotherm EPAC. And they each have their advantages, they're each great products, but mostly they each provide data. And that data I can extract and I can bring it to the user. Any questions so far?
These are individual controllers. What is an SCR?
Thank you. An SCR, that's actually the power switch.
Okay.
So this module that I showed you initially,
yeah,
that's just the temp control.
Okay.
That is just the temp control, and the power switch is a separate device.
Okay.
And it would be networked, the SCR would be networked to the touchscreen through Modbus. So you've said what your loops are, what your slots are. You've assigned your zones. If you have smart SCRs, you've assigned those. Now, at this point, you can see data. You would be seeing data. Like any basic HMI program, you can name your zones and slots to what's appropriate for the application, a user tag. Similar with the digital I/O, any that come through, you can name those as well. And the digital I/O, Allie, I'm just monitoring the digital I/O. The PID navigator is not driving anything. It's really just a runtime companion to see what's going on. The strategy is driving the digital I/O and not PID navigator.
Okay.
So let's take a quick peek at some zones. Module 1 in my setup right now is three slots of safety limit and digital I/O in the 4th slot. And if I, for instance, set a lower temperature than what's in this room right now, I should trip a safety, which I did. And the system, this is a latching relay because it's a safety. It's an FM limit. So if I try to reset it, I can't because it's still in a limit condition. So if I take it back up, now I can reset it. Module 2, that's the one we're going to spend some time on. I've got 2 loops of PID control, both controlling the same temperature, different heaters, and they're both in auto mode. And down here you see the load data. Those are coming from one of the smart power switches, the SCR. And they're relatively small loads. This amps is 0.63. The SCR is providing 33 volts to the heater. This is the heater resistance and the power that's currently being delivered. So that's what I mean on how you can look at this and you can see everything that's going on with that loop to determine its health. I'm going to kick the set point a little bit, and we should see the numbers here increase appropriately. So current's gone up, the voltage has gone up, the percent power output from the PID has gone up to support the higher temperature. Taking a quick look at what's going on, this is where the data starts really working in your favor, is how you present the data. And I mean, we're going to spend a little bit more time with this because this visual is very, very helpful when you're tuning a loop. So we're going to get to that very soon, if not now. I'm sorry, I got out of there too quick. Loop 2, the feed 2, this is more of an unstable load. And it's really not so much the load that's unstable, it's the sensor connection to the heater. And the yellow is what the PID output is trying to do to maintain temperature. And you can see just how erratic it is. And and this is mechanics, right? The sensor's really not talking, not really solidly in the process. So you're really not going to get a whole lot better than that. But I wanted to show this as an example of an unstable load, how to recognize it when you look at the graphs, when you look at the data. I mean, you're going, what is 15, 16% output, 20. I saw it down to 4, down to 0. Any questions on that?
No, that does look busy.
It is. And if you go here, now look at the yellow.
Yeah, that's way better.
So visually, this is really helpful for trying to diagnose a loop. And so I'm going to initiate an auto tune. So we're going to go to setup, back to setup. We're going to go to, I don't know, it doesn't really matter. We'll go to loop tuning. And the highlighted yellow are actually PID loops. Since you told it what's there, it knows, so it's going to show you. And then here are the tuning controls. And what I'm going to do, I'm going to change this number just so I know it. And I'm going to initiate an auto tune. Now this is going to take a while. This is not a fast process in most cases. Depending on the system, it could be relatively quick or it could be very slow. So this is what the Watlow is telling you, that where it is in the auto tuning process. So I'm going to explain that briefly. So right now, with a 160-degree set point, the loop set a temporary set point of 90% of that. So 90% of 160 is what, 144? 144? We're above 144 right now. And the power is at 0%. So the PID loop, the tuning algorithm is just watching this PV come down to that temporary set point of 144. And it's going to take whatever time it takes to get down there. So I think we'll revisit this. We'll let it continue to tune, and we will revisit this. and then you can see graphically what it's doing. Now, one of the add-ons that I did was something called that I called guided tune, and this is a little bit of me and my experience with PID. The first thing is, okay, when you get a controller out of the box, it has a default tune, and a lot of times that's okay. But there are times when it's not. And going through this, you can click, is it the decision-making process, the flow chart, is the tuning good? How do you check if it's good? Well, you can graph it. I mentioned a story about Owen, and when I was early on in my Watlow career, um, I was working on a job and I just was having all kinds of trouble just tuning and just helping the customer out. And so I called Owen, I talked to him about it. He's out of state, so it was difficult to bring him in. And he goes, tell you what, he goes, I want you to send me um, a, a graph showing the PV, the temperature, the percent output, and the set point, just like this, but running in runtime. He goes, just send that to me. And I said, okay. And this was a while ago, and data wasn't as prevalent then as it is now. It was, you could get it, but I went through with the customer to get the data, and I sent the graph to Owen, and I heard from him later on that day or the next day. He goes, okay, here are your PID values, whatever number they are, P, I, and D. He said, put those numbers into the controller and it should work. And Elliot did.
That's awesome.
He went from this to P, I, and D numbers to inside the controller, and it worked. And I just was dumbfounded. I mean, that was amazing to me, and I just tried to interact with Owen as much as I could in my years with him, just to learn. And when you've got a mentor like that, and you can work together, it will serve you well, over the years. And I can't do it. I mean, Owen would have forgot more than I'll have ever known on PID, really. But as if you my learning was to, well, okay, I don't know the mathematics, right? I just don't. But I could learn the tools, and that's what I strive to do, was to learn the tools. And that's what I wanted to bring out in the software. So what you see here, the controller went to 100% output because the PV got below that temporary set point of 144, and then it got above 144 like here, and now it's off again. So it's going to do this one more time. You're going to see this go to 100% power and then back down, and then the process can go above that temporary set point, below that temporary set point, and then I believe at that time it will lock in the PID numbers, and it'll go into runtime at that point. So anyway, the visual, nothing beats this really for looking at a PID loop. Just to me, the visual, it's worth a picture's worth 1,000 words. And if it's not good, if you determine it's not good, there's some verbiage here to general rules of thumb. Here's an different auto tune screen. But this one, in the guided tune, I actually included the starting PID numbers in the current numbers. So if you do an auto tune, the new numbers will change, but the previous numbers will stay the same. And these numbers aren't in the controller, Allie, they're gone. But you see now the new numbers, and you see now the difference in the graph. And now you can learn What difference did that make?
Awesome.
So we're still going through. We're waiting for cross negative. When this gets below, well, we'll see what happens when. Yeah, it's because it's going to go 100% again. So this has to float to below 140, 144. So it's going to take a little bit. So now we're back to our guided tuning. So let's say this process isn't good with auto tune. Not every process can be auto tuned, frankly. On the watt lows, again, I'm picking on them because I know them. It'll try for an hour, and if it can't tune in 1 hour, it will just kind of stop and not change anything. So on a very slow process where there's a long lag time between when you turn on heat to when you actually see temperature, when that's a very long time, um, it might not tune. So you might have to go to a manual method. So again, here's our is it good kind of question, and it's relative, but it is the question. Um, let's say it's not. There is another tuning algorithm inside the Watlow. It's they call it True Tune Plus, and this is a runtime tune. Whereas auto tune, you're kind of offline. It's doing its thing. It takes over the entire loop. True tune's a little different. It operates when you're at set point, and it's slow. It is slow. You can even see here we're still auto tuning. But yeah, we got below 144, so the output turned to 100% alley. So now it's going to watch it come back up. Um, in fact, this might be a good time to talk about the best tool in the toolbox for tuning a loop. And I don't want to be kind of too cute about it but really you can't buy it, but in a way it costs a lot of money, and that's patience. You need to have some patience when you're tuning. I know you have experience with PID loops, and you just have to have patience. And if you do, you will be rewarded. Now, patience is one thing, time is another, right? And time costs a lot of money sometimes.
Absolutely.
So with True Tune, uh, generally, when this is turned on here, I will turn it back off, or the software will turn it back off at the appropriate time. That's because True Tune, it's, in my opinion, it's good to use in a lot of cases, but not necessarily to leave it on full time. So I will shut that off. So let's go back to loop tuning. Let's see where we're at. So we're at 158 degrees when it comes down to below 140. I think it was 144. It's going to flip into runtime. Let's take a look at our unstable loop just for a second. Let's see how it's doing. Not much better. It's you'll know. In the years I've only had, maybe I could count them on one hand, the number of unstable control loops where they just wouldn't tune. And it's really comes down to the mechanical design again. That the control's great. A lot of people make great controls, but if the process is not mechanically stable, you're just not going to be able to get to where you want to go. And it's interesting because you look at the power output and it's kind of erratic, right? But the temperature is, well, on a 150-degree set point, it's kind of hanging around 150 degrees. So you can have issues with controlling um, but still be able to maintain some semblance of temperature, right? I mean, it's like driving from Baltimore to Cleveland. You can drive you can drive 0 miles an hour and 100 miles an hour, and another guy can drive 50 miles an hour. Guess who gets there at the same time? You know, it, they both get there at the same time. But 50 miles an hour and 0 miles an hour and 100 miles an hour, um, you're not in control. So if you see the power output, to me, that's what you want to pay the most attention to, is the power output. If the power output is stable, then the process will be stable. Sorry, let's take a look. And we're at 147. So pretty soon we're going to go below 144, and then we will flop into runtime. Any questions? What do you think?
That's cool.
Again, the patience thing. You have to have patience, and you can get gray hair waiting for a loop to respond and let you know how it's working.
How do you know that you're, well, I guess you can look at the graph, but that you're, do you know offhand, can you give some examples of like non-tunable loops?
I wish I could. Well, maybe in a way. If someone is doing heat and cool, okay. Now, Watlow, they don't make coolers, chillers, that sort of thing. They're pretty much heat only. But I've worked with a lot of coolers and chillers over the years, just on the control side when someone's doing a heat and cool control system. I'll just take an extreme example. Let's say you have, pick a number, 1,000 watts of heating power, Allie. That's what you have, 1,000 watt heater. And then let's say you have, I don't know the comparison, the conversion. Let's say you have 20,000 BTUs of cooling. Well, you're not really matched, right? You have way more cooling power than you do heating power. So when the chiller turns on, it just absolutely engulfs what you had going on with heat, and it engulfs what you're capable of delivering with the heater. And so what ends up happening is the process temperature drops rapidly once the cooler turns on, because it just overwhelms the system. That is one example of what I'll call a balance, a mismatch in your heat power and cool power. Others might be sensor placement. If sensor is placed way too far out, like if you want to consider like a big old oven, and you have your heater here, and then you have your sensor way over there, it might take, in a big oven, it might take 5 minutes for the heat to get there. It just makes that doesn't necessarily mean it's unstable. That means it's just going to be difficult to tune.
Okay.
So they take many shapes and sizes, Allie, on what's considered, okay. Infrared heating, when you have a panel, an infrared panel, a lot of times a good way to control temperature is just strap a sensor on the heater itself and just control the temperature of the element, the panel that way. And then underneath, you have the object to be heated, and you just use time and temperature to get the object to where you want to be. So you just adapt to how it's best to deliver to deliver the power and control the heater. In that case, you're really not you're really not controlling the temperature of the part, right? You're controlling the temperature of the heater and using time and distance
Okay.
to work the process. If something's coming down a conveyor or something, something like that. But this seems to be doing, you can see it came out of auto tune and now it's in runtime mode. And it's just, it looks happy as a clam, really. And what we're doing here is really just how to tune a loop. Yeah, there's the mathematics of the P, the I, and the D, but patience and understanding, and in this case, using the tools that are available. Um, so this is the guided tune. Data log, this one I still have locked, but there's just a real simple lock and unlock code. Um, Now you have some data logging capability inside. Let's go back to the zone display. There's a zoom out and a zoom in. This is 4 slots per page. If I zoom out, I can do up to 8.
Nice.
And just a little bit more high density is all. And less information, the load information is sacrificed. Or we can zoom in, and now we're on one slot. Let me go to that first. Yeah, here we go. This is the loop we just tuned, and so now we kind of have a page dedicated to that loop, and we have our load data, and we have our graph, and we have our text based. So we have all the information. We can change the time base if we wanted to. Where we can bring in more information. So um, this is PID Navigator, Allie. I guess that's probably the best way I can word it. This
I
this
love it.
is Thank you. This to me is the tool I would have, liked to have, when I was selling the multi-loop temp control systems. But now, because I'm independent, because I do the integration, I can, actually get the control panel done. There's a lot more capabilities that I have now in terms of the customness of it. Um, Let me go back to here and here. Loop management, I'll just show this real quick. Um, it's really just some optional things. Remote set point, if it's a cascade, we never really got into cascade control and ramp action. There's the Watlows can ramp to a set point and just ramp the temperature in a controlled manner to get from set point A to set point B or all the way down. This can be defined by the user. After you get the loop tuned, that's when you would get into that. The limit, this was the one I toggled earlier. I'll pull the connector on it again. Module number 1. This should be it, I think. Yeah, that's it. Put it back in. And here's where you can set the maximum allowed operator limit setting. Here's the actual set point, and if you want an optional alarm, you can put that in there. If you do have a limit, I think I should be able to show it. Yeah, and it shows up down here. You go to limit management, and the one outlined by red would be the culprit. So I'll go ahead and reset that one. There is a bar graph display as well if you want the comparative display. It's just simple, not it's just a bar graph, but it allows you to have the compare between the zones, between the loops, if that's important to you.
Could be.
And I think that's about it. Alarms, there is alarm setup here for those temperatures that you have. If I can, I might show, if you want me to, I'll show the vendor software, the Watlow software, real quick. It's up to you,
Sure.
and see how it works with that. Our loop is doing nicely. Okay, so let's
That
see
looks
if
beautiful.
I can do this. I'll start up the software now, the Watlow software. And then let's see if we can get into it.
How can uh how can someone get your software? Do they have to have you be an integrator, or how does that work?
That's a great question. Thank you. You can go to pidnavigator.com. It's a base price of just about $2,000. The add-ons are $250 each. Watload distributors, certainly here in the southeast Michigan area, Michigan High Watt is a distributor for it. And I would say any other distributors, Watload distributors, feel free to give me a call because they're in the best position to sell this because they sell the Watlow already. And this works with the Watlow, and I can work with the distributor to on the data table portion. So I would start with pidnavigator.com and we can go from there.
Okay.
Do you do you see the software, the Watlow software?
Yes.
Okay, so what it's doing is it's going out to the rack that I have here, and it's discovering the modules. And it's going to take a minute. Module number 2 is the one that we've been picking on loop number 1. And module 2 just has in its features more features, so it just takes longer to discover what's inside. Okay, so we got it. And it's a graphical program. Um, and here we go. You should see the graphical representation, Allie.
Yeah.
Great. So this is the loop we've been messing with. This is the one that was used for compare. The unstable loop here, the stable loop here. And here's the PID block. You can see the input, thermocouple input ends up going into the PID block. And these are the PID block settings. And PID Navigator is not a replacement for this. No way, shape, or form. This is the vendor software to set up the hardware, diagnose, troubleshoot. My PID Navigator can assist with some of that, but this is where you would set up your strategy and handle any modifications to that. So PID Navigator is really a runtime ally for you. It does not supersede the Watlow Composer software, if that makes sense.
Yeah, that makes sense.
Okay.
What if you don't know where to start with your PI and D? Is there recommended resource for that?
Wow, that's a great question. I know Watlow has some white papers on their website. I would look there for
Okay.
any information on PID. Certainly, it would apply to their particular controls, and I'm sure it would have a universal value as well. Um, Beyond that, yeah, it's a great question. In terms of resources, any forums, I'm sure, but I'm not aware of any particular forums, Reddit, um, LinkedIn groups. There is a LinkedIn group for temp control. I did set a request to join them just very recently, just a day or two ago.
Okay.
So that is a resource that me personally, I looked at was LinkedIn. But yeah, at some point you've got to you've got to put some time in with some loops. But yeah, you're right. You do have to prepare. If you can prepare by any reading, please please do. The Watlow instruction manuals for the easy zones does have information on it about the settings and description of them. And there's also some description of I'm not quite sure the right words, Allie. Further reading, I guess, is probably the best way I could word it.
Okay. And then if people want to reach out to you, what is the best way to do that?
You can find out, get in touch with me at cardinalbest.com, www.cardinal, like the bird, best.com. My email address is jvirag, V like Victor, IRAG like George, at cardinalbest.com, or through the PID Navigator website as well, Ellie.
Great. Well, it's been an excellent session. Thank you very much for showing this to us.
Oh, thank you. I hope it wasn't too boring.
No, I liked it. And look at that control. That's beautiful.
Yeah, it's just it's I'll tell you the most the highest compliment I've gotten when I'm at a startup helping a customer out is when the control starts working, the customer forgets I even exist. It's like I'm invisible. And you know what? That's because they don't need to worry about this anymore. They move on to their next issue, their next problem, their next challenge, and they forget. And it's like I smiled. I was in a startup earlier this week on a PID control system eating oil, a very difficult oil. And the stuff is nuts. I mean, it's a solid at room temperature, and then it goes through a phase change, and then the temperature just takes off to the moon. And and we got it working, and then all of a sudden the customer forgot I was there, and it's like, okay, this is good. It's a compliment, believe me. And I hope, those of you watching this, you've been in a similar situation. And it's just not about temp control. It's just you doing your job and helping the customer, right? It takes many shapes and many shapes, sizes, and forms.
But yeah, at the end of the day, making that customer happy is what matters.
You bet.
Well, thank you very much, Joe.
You're welcome. Thank you, Allie. Thank you to the automation ladies. This has been a pleasure, and I'm just way grateful. Thank you. This is awesome.